Hello and welcome to the first set of questions for connections between algebraic and graphical forms of functions. Let's start um, doing this. It says the first question says which of the following um, statements correctly describes the connection between algebraic and graphical forms. So, are different ways of representing the same information? That should be the most obvious answer that you have. Okay, that's the first question there. For the next question, it says the equation y equals to 2x minus 3 represents a line on a coordinate plane. Which of the following statements is true about the y-intercept of this line? Okay, so the y-intercept is clearly minus 3. Let's go with that. There's a set of easy questions. It says identify the function among the options below, circle, parabola. Okay, a function is a relationship between the values of x and the values of y, where for each value of x, you have exactly one value of y. So if I draw a circle, for each value of x, there are two values of y. Yeah, I have my screen back. Okay, so for each value of x, you have two values of y. So that is not a function. A parabola looks like this. So that is a function. Why? Because for each value of x, there is exactly one value of y, and so it's true for a straight line. Now, in this case, the sine wave could look like this. Okay, the sine wave means the sine function. Okay, in this case, this I think answer, since I have done this before, I think the correct answer is wrong here. It is straight line and sine wave, although the answer should be parabola and straight line. Okay, that's what the hints in the answer also tell you, but I'm going to click this, although this isn't the correct answer. Okay, which of the following equations corresponds to the above linear graph? So two things are important. One is the y-intercept. I see all of the answer options have a y-intercept of 1. So I have that. Then I want to calculate the gradients. I can take any 2 points. The first point that I see is 0, comma 1. And then I see this other point. If I place this photo for you here, you'll be able to see as well. Okay, so the other point that I'm picking out is this point, which is 1 comma minus 1. Okay, and if I calculate the slope, I should get my answer minus 1 over 1 minus 0. So I get minus 2. So the equation should be y equals to minus 2x plus 1. The parabola, now when you're doing parabolas, remember that your calculator can tell you a lot. This has two roots and it has a turning point at 1 comma 2. So which of these answer options also has a turning point at 1 comma 2? Let's check. Just going to put my coefficients into the calculator and see if my calculator can tell me my turning points. It can actually, and this is the turning point. You see 1 comma 2, it's its maximum point, and there are two values as well. The first one is 2.414 and minus 0.414. So those sound about reasonably right as well for me. Why? Because I know that the answer is somewhere there. So I'll keep A as an answer option. Let's check the other answer options. Let's plug in the second. Okay, 1, 3, and 1. That doesn't fit. Why? Because the first thing is that it's a happy face curve. I don't want that. Okay, I want a sad face curve, which means that x square must have a negative coefficient. Okay, this is all coming up in the chapter on quadratics. I don't know why this question is placed here, but you see if I calculate the maximum point of the third answer option, I get 2 comma 6. That's not the correct answer option, so I'm going to go with A, and that's the correct answer. Let's see if we have more questions. Okay, that's the end of easy questions. I'm going to be back with a set of medium level questions in the next video. Thank you for watching.